Hi everyone, this video is on exercise 9I of PO2. So in this exercise, we have questions about convex and concave functions. And also in this video, I'm going to do questions A and B. So before I start doing the questions, let me remind you that a concave function is a function such that, so in concave function, we have f dash h f dash x is less than or equal to 0. So this is the concave function. And the convex function is a function that f double dash x is greater or equal to 0. So just to show you a quick example for each of them, just to get an idea, a convex function, an example of that is simply, let's say the function f of x is equal to x squared. So this is a convex function which has this typical u-shape form, and as you can see the function is increasing, whereas in a concave function, as you might have guessed, an example is f of x is equal to minus x squared, which is like this, and this is a decreasing function. And so these are some important points to remember, but let's see how can we use this in practice. So in part A, we have the function x cubed minus 3x squared plus x minus 2. And we want to find the intervals on which the function is both convex and also another interval that the function is concave. But before doing that, we just need to find f double dash x. So f dash x is equal to 3x squared minus 6x plus 1. F dash x is equal to 6x minus 6. Okay, now we can answer part I, which says where the function is convex. So as we said, a function is convex when f dash double dash x is greater or equal to 0. So we can just solve this inequality. 6x minus 6 is greater or equal to 0. And this gives us x is greater or equal to 1. And we can write this as an interval like 1 to plus infinity. So this is the interval where the function is convex. Now, we also need to answer the second part, because this is the part for being concave. And this time, when f double dash x is less than or equal to 0, that's when it's concave. And it's just the same, basically the function, but the inequality is slightly different. So for the answer, we are going to get x is less than or equal to 1 this time, or as an interval, this can be written as minus infinity to plus 1. So these are basically the two intervals that we have. That the second one is when the function is concave. For the first interval, the function is convex, or at least f dash x, f double dash x. So it's out of habit that I keep saying f dash x, because you don't normally, talk about f double dash x. Anyway, now let's do part B. Okay, part B, we have this function, which is another polynomial. And in part I, we want to show that the function is convex. But let's find the second derivative first. So f dash x is equal to 4x cubed minus 9x squared plus 2. The second derivative is equal to 12x squared minus 18x, and we have a quadratic. So let's solve the quadratic first, just or actually we don't need to solve that right now, we can just factorize that. So I'm just going to write this as 6x times 2x minus 3. Okay, now we can answer part A, which is about finding the interval where the function is convex. So that happens when the second derivative is greater or equal to 0. And we have 6x less than 2x minus 3 is greater or equal to 0. And the solutions to this are obviously the roots are either x is equal to 0 or x is equal to 3 over 2. So that's obvious. Now, if you want to solve this inequality, you can always sketch the graph of this function just to get an idea. Because if you sketch that, you have something like this. This diagram is not the best, but basically the idea is that this inequality is saying whenever the graph is greater than 0. So as you can see, you have this tail of that and also this tail. So both ends of the graph, the tails basically are the parts that we are interested in this case. So that means the solutions of the inequality are either when x is less than or equal to 0 or when x is greater or equal to 3 over 2. And as intervals, we can also write them as minus infinity to 0 and basically 3 over 2 to plus infinity. So here saying and is not very correct. We can just use the union just to say that we are including all of the intervals. So yeah, this is just set notation. Okay, so this is the solution. Now for the next part, which is showing that when the function is convex, this is when the inequality is less than or equal to 0, which means 6x times 2x minus 3 is less than or equal to 0. So this part is when, if you again look at the graph, this time we are talking about the parts of the curve that is less than 0. It has the y value of 0. So that's this part of the this quadratic. So this part. Or maybe if I show on a bigger diagram so you can see exactly what's going on. So we have something like this, and the part that is less than 0 is like here. So it's between 0 and 3 over 2, in fact. So yeah, we can just say this happens when x is between 0 and 3 over 2. By the way, 0 and 3 over 2 are the roots of this function. And as an interval, you can write this as 0 and 3 over 2. Okay, so that's it for this video, and thank you for watching.